Okay, well, last thing we left off, we were just trying out our new class that registered two different interface types. We registered an interface to class A and an interface to class B, and then we tried to resolve class C, which is looking for in its constructor an interface to class A and an interface to class B. So that's the contract that this class needs to construct or instantiate. And these are the definitions used to satisfy the construction of that class C. If either one of them missing, as we saw in the previous video, this resolve would throw. We get an error saying it could find one of the required elements, and it would tell you which one it was. And remember, we have this thing left in here. This is where we register an instance of a class. So we constructed a class A, we set a message to it, and then we register that instance. Now we run this, we'll see what happens. So we got our Unity container. We create our class A that has the message. This is a test. Class B, we register the instance of class A. We register the interface of A with the hard class invitation of A, and register the interface of class B with the hard class interface hard class construction of class B. And then when we resolve class C, we look here under class C and we see that A this is a test, and B is a number 0. Now we could show you, you would think, well, it's just pull nose. Well, it's not. If I were to take this class B and do the same type of thing, I'd say number equals 32, and if we run that and step down here, if you can imagine, you're probably thinking what it is. This is a test, and B is 0. So why? Why does the simple class versions of A, why does it have this as a test and the other one doesn't? What we is this line right here, register instance of A. So when we register that instance, we're saying, here, Unity container, this is a class A that's already constructed. Use this for class A's, and it does. When we resolve this guy down here, it says we need an interface of A. Well, I've got an A, because my register type says an interface of A is equal to a class A, and we've already got one right here. Use that one. That's how you have what we talked about in the last video, which is a common singleton object that you use in multiple places. That's how you do it. That isn't the best way to do it, but that's a way to do it. Let me show you a better way to do it. So I will stop this, and we will delete this register instance line. And just to show that this is now unhooked, we go down to class C, we look at it. A is now a null, B is a number 0. So these two are no longer even used. Okay? Okay, so what I would do is I would go to class A, and in these arguments we can add a new argument here. And what these are is these are lifetime managers. Now I think there's only 1, 2, 3, 4, 5, 6. 6 of them in here. These injection constructors, I don't even know what these are. I've never used them. I'm sure they're cool. Maybe I can figure out what they are and do another video later, but I don't even know what they are. The only ones that I've ever really used very much, and some of these I read through them, they're interesting, is the container-controlled lifetime manager, which means, I'll explain in a second, and transient lifetime manager. Those are the only two I've ever used. So we're going to do this one, container-controlled. And if I read the little tooltip here, it says, a lifetime manager that holds onto the instance given to it. When the container control manager is disposed, the instance is disposed with it. Tongue tie. So if I use this, what it's saying is, the first time that Unity constructs a class A, keep a hold of it, and anytime it's used after that, or anyone's requesting it, give them the same one. Okay, so let's step through this, and we'll show you this container-controlled lifetime manager. So if I step through this code, create our class, ask for a lifetime manager. Now when I pull this class, this class up here, this is a class we constructed. Unity doesn't know about this one. So I would expect that this class C has a null for its message and a 0, so that's the default value for a number. So it didn't use this guy here. So to get it to use that guy, all we have to do is down here, I'm going to say a class A1 equals, and I'm going to have a unity give me a class A. So I can say IOC resolve a class A. Yeah, I think that'll work. And right after that, I'll say A1 dot message equals, oh boy, hello world. Okay. Now let's try it out. So we step down here. We have an A1. We set its message to hello world. I get a class C. What did we get? Notice in class C, when it pulled down the container controlled lifetime manager version of the class A. So this is the right way to do it. You can use the registered instance. That works, and there's parts where that's great. This is better. This just says whoever in all the code constructs it first, let's just keep that one. Instead of you having to create a special spot in code where you say, these are my special global singleton instances, you construct them all, and then you save them all in there. That's a little dirty. This is just, in the definition, you say, keep the first one you make. And that's what it does. And I could do that with either one of them. I could do a container controlled on the class A, class B, even class C, and it'll keep those instances. So we've learned that to create a Unity container, we just say new Unity container. That Unity container has to stay alive, so you need to put it into a global, because this is a one-time construction. Keep it. Then, when you want to add classes to Unity, you register either the class itself with register instance or a class type, preferably an interface, but you don't have to. You can register just the class A, and that works fine too. But we're registering the first variable of the parameter is the interface, and the second one is what's the hard class implementation of that interface. And then we learned that we have two parameters in here. If you don't put any parameter like class B, that means it's transient. And I will demonstrate that real quick. But that means if I were to come in here, well, let's just do a new one. Let's say class B, B1 equals IOC.resolve class B, and then say B1.number equals 66.4. If I were to run that, we should not get that one because the default constructor for a register type is a transient. Transient means every time we ask for it, construct me a new one. So here we have a number is 664. I look in here, my class B has a number 0, so it's a new one. They're not the same guy. Whereas this A is the exact same class as I just got a second ago. So then once we want to construct those bottom classes that have layers of classes infinite deep, you can have classes that require classes, or require classes, which require classes, and all those will be resolved when I say IOC resolve. It'll give me back one. It's a great way to do complex hierarchy code. It's a great way to keep your definitions clean. All around, it's a great engine to use. Now, just as a word of note, I'm using Unity, but there are many out there that are in a dependency injection, inversion control containers. There's Ninject. I know that one. A lot of people really like it. I can't remember any other on the top of my head, but there's quite a few. And all of them have the same principle. It's just different syntax. So I hope you've enjoyed learning about inversion control and dependency injection. See you next time.